Good morning, everyone. It is an honor to be here with you at LSA 2025. My name is Gianluca Tramontana, and alongside my colleague Luis Shirota, I'm here to present our research entitled Improvement of Productivity by Applying 5S, Work Standardization, Ergonomic Analysis, and Poca Yoke in Metalworking Company. Number of paper 409. Let's begin by discussing the background that led us to develop this study. In recent years, the Peruvian metalworking sector has grown significantly, representing more than 1% of national GDP and almost 10% of the industrial gross value added in 2022. It also provided over 430,000 jobs with more than 44% increase in employment. However, this growth was threatened by the economic crisis caused by COVID-19 pandemic. In 2021, Peru faced almost 7% inflation rate, and factors like political instability and declining international demand further weakened the sector's competitiveness. While countries like Chile, the US, and China are already applying lean tools and smart manufacturing technologies, Peruvian companies are still dealing with low productivity, lack of digitalization, resistance to change, and non-standardized processes. This is where lean manufacturing becomes essential, offering strategies to increase efficiency and competitiveness. Previous studies have shown that lean manufacturing tools such as 5S, Poca-Yoke, and standardization can significantly improve performance. For example, 5S implementations have increased productivity by 8%, Poca-Yoke reduced rework by 30%, standardization cut waste in times by 81%, and improvement on time delivery by 30%. These tools not only improve operational performance, but also enhance quality and employee satisfaction. Based on this background, we set out to apply lean tools in a Peruvian metalworking company to tackle the specific problems we identified. Through our diagnosis, we found the following problems in the polishing and crown plating area. First, productivity was low with 18 units produced per labor hour. Efficiency was also limited at 81%. We observed a high rate of human errors, 33 mistakes per quarter, and almost 30% of all parts required rework. In addition, idle times reached 280 minutes per quarter, and the absenteeism rate was more than 8%. These indicators pointed to significant ineptitudes that were negatively affecting profitability, quality, and worker well-being. That led us to design a focused improvement proposal. Our improvement plan involved three key components. First, we applied the 5S methodology combined with work standardization in the polishing area. Second, we addressed ergonomic problems that were affecting absenteeism and rework. And third, we implemented a Poca-Yoke solution in the crown plating stage to reduce human errors. Each of these components was designed to be low-cost, feasible, and sustainable for the company. Now let's take a look at the problem we identified in the company under study. We compared several key indicators between the company and the overall sector average. The results revealed several performance gaps. Productivity was significantly lower, at just 18 units per man-hour, compared to the sector 33. That's a 45% decrease. Efficiency was also down by nearly 40% at 81% versus the sector's 94%. The reprocessed parts percentage was slightly higher at 28%, which is almost 12% more than the average. One of the most critical issues was the frequency of human errors in polishing, which reached 33 errors per trimester. That's 65% higher than the sector benchmark. Unproductive time totaled 280 minutes per trimester, represented a 40% increase. Finally, absenteeism stood at almost 9%, which is 74% higher than the sector average. These baseline metrics clearly highlight multiple areas where performance was below industry standards. They provided a starting point for improvement efforts and allowed us to quantify the magnitude of the problem. To solve the main problems, we propose an improvement plan based on 5S, work standardization, ergonomic analysis, and Poca-Yoke. We first analyzed the company processes and collected data on key indicators like errors, productivity, and absenteeism. This helped us identify the main incompetencies. The proposal consists of three components. Component 1, implementation of 5S and standardized procedures to organize workstations, improve time management, and ensure consistent performance. Component 2, ergonomic improvements such as better furniture, workstation redesign, and operator training to reduce strain and absenteeism. Component 3, error proofing through Poca-Yoke systems, process standardization, and safety measures to reduce human error and improve quality. Together, these actions aim to boost productivity, reduce waste and rework, and create a safer, more efficient work environment. Let's start with 5S and work standardization. Our goal was to improve workplace organization and ensure consistent execution of tasks. We implemented the 5S: sorting, setting in order, shining, standardizing, and sustaining. We introduced mobile carts to keep tools organized and close to the work area, reducing unnecessary movement. We also standardized the tasks performed by operators and defined protocols to reduce variation. As a result, idle time dropped by about 10% from 280 to practically 254 minutes per quarter. Efficiency improved from 81% to nearly 88%, seeing our initial expectations. The second component addresses ergonomics. We conduct service and anthropometric analysis to understand operator discomfort. We then acquire adjustable chairs adapted to the height and posture of each worker. Additionally, we implemented standardized workstation configurations and maintenance plans to ensure consistent ergonomic conditions. The goal was to reduce absenteeism to 7.5% and rework to 26%. As a result, absenteeism decreased from 8.72% to 8.3%, and rework dropped almost to 23%, even better than expected. This shows us that simple ergonomic interventions can have a strong impact on productivity and quality. Finally, to reduce human error in the chrome plating processes, we implemented a Poka-yoke system. We installed a semi-automated monorail that physically guides the material through the process. This solution helps prevent mistakes caused by human distraction or fatigue. Operators were also trained to follow standard parameters to ensure consistency. With this intervention, human errors were reduced from 33 to 25% per quarter, a 24% improvement. To validate the feasibility of our improvements, we developed a simulation model in Arena software. This model replicated the company's current process and compared it with the improvement scenario. The simulation confirmed that the proposed changes were operationally viable and generated measurable improvements in key indicators like productivity, efficiency, and idle time. From a financial perspective, the results were highly promising. The project had a net present value of practically $1.8 million, an internal rate of return of just 67%, and a payback period of 1.41 years. The benefit cost ratio was 1.43, meaning the company earns $1.43 for every dollar invested. These results demonstrate that lean tools not only improve operation, but also deliver strong economic returns. We also performed a sensitivity analysis to assess to project robustness. We found that a 15% decrease in the product selling price will make the project unfeasible, with a negative NPV. However, if prices increase by 15%, the NPV rises to $6.67 million. Even with a 20% drop in sales, the project remains profitable. Under the most optimistic conditions, the NPV could reach $13.56 million. This result shows that while the project is somewhat sensitive to price variations, it remains highly profitable under most realistic scenarios. To conclude, the integration of 5S work standardization, ergonomic analysis, and Poka-yoke led to a 21.67% of increase in productivity, going from 18 to 21.9 units per labor hour. We achieved improvement in efficiency, reduced rework and human error, cut down idle time, and lowered absenteeism. Simulation confirmed the feasibility of the redesign, and financial analysis shows strong returns with minimal risk. This study demonstrates that lean manufacturing tools, when applied strategically, can generate significant impact even in traditional sectors like Peruvian metalworking. Thank you very much for your attention. We're happy to answer any questions.